Second day on this. More adding and subtracting of rational expressions. So rational expressions, remember, those just really mean that they're fractions. And we're going to be adding and subtracting these things. So first off, we're going to have to recognize that sometimes they look a little bit different. This is x plus 5 and x minus 5 on the bottom. This is minus x, so it's kind of backwards, plus 5. So careful, this is not the same as this. This is x and 5, they're both positive. This is x and minus 5, one's positive, one's negative. This is minus x and 5, one's negative, one's positive. So these two can be turned into each other. So here's what I want to do. I'm going to factor out, so in other words, divide out negative 1 on the top. Go away. So what's going to happen? So I'm going to go negative 1, bracket, and negative x divided by negative 1 is positive x. And 5 divided by negative 1 is minus 5. Now do you recognize? See, there it is on the bottom. There's that x minus 5 factor. X minus 5 and x plus 5. Now that I've factored it, I can cancel these two out. So this becomes negative 1 over x plus 5. And that could be in brackets or it doesn't really matter. And because it's the only factor now, it doesn't really matter. Now, x plus 5 and 5 plus x, I know that those are the same thing. If it's adding, I don't care about the order. But if I'm subtracting, yes. So minus x can be turned into x by dividing out the minus 1. Then once you cancel these out, then I can put it into simplified form. So okay, so let's try a few more of these. These are kind of like the ones we were playing with on Tuesday. So what do we got here? This is 1 over a trinomial. I know that this is going to be two factors. Yeah, two numbers multiplied to negative 12. So it's x plus 4 and x minus 3. And by luck, there it is. There's the other factor, x minus 3. Okay, so remember, we did this with the lowest common denominator. We said, hey, let's do a Venn diagram. We'll see what overlaps. They do have something in common. The left denominator is x plus 4, x minus 3. And the right one is, okay, so x minus 3, they have that in common. So the left one is x plus 4 times x plus minus 3. And the right one is just x minus 3 times 1. So that's the LCD. It's really this times this times this. It's all three of those. In other words, it's this. This is the LCD already. This one's done. This is the one where I need to put in the other factor. So really, I need to insert a factor of x plus 4. So I need to multiply that not just at the top, I need to do it to both top and bottom. Okay, so this I don't really need because it's kind of in the way. So let's get rid of this. Let's get rid of this stuff. Go away. So here's what I'm going to do. I'm going to multiply this one over here by x plus 4 because that's the missing factor. I need x plus 4 and x minus 3. Now I can't just do it there. I have to do it, multiply it on top and bottom. Oh, that's right, because really what I'm doing is I'm multiplying it by a convenient form of 1. This is really 1. That's all I'm multiplying by, right? So if I multiply by that, okay, let's go back and do this now. This one's already done. So this has 1 over x plus 4 and x minus 3. Oh, this is terrible. Plus 3 times x and 3 times 4. So plus 3x plus 12. Because this is, once I have the same denominators, I can write it as one big fraction. Now, I didn't cancel those out. No. I'm not canceling because I want them to be there. This way I can write it as one big fraction. Now, the top, I can combine stuff. Sure. Yeah, so what do I have on top? I've got 1 plus 12 plus, so I've got 3x plus 13. Nothing factors out of that. I know I'm done now. And the bottom is x plus 4 times x minus 3. Now, should I expand that all out back into the original trinomial? Don't bother. Leave it in factored form. This is done. Am I done the question? Simplify and give non-permissible values. Okay, so what is my x value? So yeah, so x cannot equal, well, I know it cannot equal negative 4 because that would give me 0. It cannot equal positive 3. Are those the only two denominators? Minus 3, positive 4, positive 4. Yeah, that's it. Those are the only two. So those are my only two restrictions. So those are restrictions, and that's what it is simplified. Okay. How about this one over here? This one's not so easy. This one's got 1, 2. Yeah, I've got a whole bunch going on here. So once again, let's factor. Two numbers multiplied to negative 6. So no, it's got to be 3 and 2. So x plus 3, x minus 2. What about this thing? Oh man, this is going to be big. So this is going to be x bracket x squared plus 2x minus 3. Two numbers that multiply to negative 3. Oh yeah, hang on, I can factor this thing. Two things that multiply to negative 3. It's got to be 3 and 1. So what will this thing factor into? X plus 3, x plus 1. No, that would give me 4 in between. And besides, I want this to be minus. This is going to be minus 1. There we go. Now it's actually going to work. So here's, whoa, this is a pretty big denominator. The LCD. So the lowest common denominator. Do they have anything in common? X plus 3, x plus 3. That's x plus 3. That's what they have in common there. So the left-hand denominator is x plus 3 times x minus 2. There's my left-hand denominator. And the other one is x plus 3 times x and x minus 1. So 1, 2, 3, 4. This thing is going to have 4 denominators. That's what I want to create. So I want to create 1, 2, 3, 4 different denominators, all of them together. So with the first one, here's what we got. 2, and this is x plus 3, x minus 2. Is that what we got? Oh, that's a terrible x. I need to have an x, and I also need to have an x minus 1. So here's what I'm going to do. I'm going to multiply top and bottom by x, x, x. I'm also going to multiply top and bottom by x minus 1. There we go. So that one I've multiplied top and bottom by the same thing. Okay, let's go over to the other one. Plus, here's what we got. We got 3 over, I got x, x plus 3, and also x minus 1. So what am I missing? That's a 1. I'm missing x minus 2. That's what I want to multiply top and bottom by. So I'm going to go x minus 2, multiplying the top and the bottom. Okay. Now I've got 1, 2, 3, 4. 1, 2, 3. Yeah, I've got all of my denominators together. So now I can start putting stuff together. Okay. Let's do it. This becomes 2x times x. So in other words, 2x squared. 2x times 1 is 1. So minus 2x plus 3 times x. 3x plus 3 times minus 2. Minus 6. There's my top. And the whole thing is all over these 4 factors. Here we go. X plus 3. X minus 2. X. I'll put it here. And x minus 1. Now, at no point do I want to multiply these all out. I'm just going to leave them all in factored form. I can't really cancel anything top and bottom, but I can simplify the top, right? So notice I've got 2x squared, 2x3. I can put these two together. So hang on, what do we get? We get the top is going to become 2x squared plus 1x minus 6. The bottom is x plus 3, x minus 2, x minus 1. There's my 1, 2, 3, 4 factors. This thing looks like a trinomial. I bet you this thing will factor. I bet you it will. Let's see. This is 2 numbers. Think about it. If we do this by decomposition, 2 numbers that multiply to negative 12, and they add up to the middle, add up to positive 1. So in other words, it's got to be 4 and negative 3. Careful. This is not x plus 4 and x. No. This is 2x squared plus 4x minus 3x minus 6. Remember, factor out here. I can divide out 2x, bracket, x plus 2. Here I can factor out minus 3, bracket, x plus 2. There it is. I can see it now. It's x plus 2 is one of my factors, and the other one is 2x minus 3. Okay, so this becomes x plus 2, 2x minus 3 on the top. The bottom is these 4 factors. X times x plus 3 times x minus 2 times, oh, I see it. X plus 2, oh, hang on. This is x plus 2, x plus 2. These both cancel. Does this cancel? No, these do not cancel. It was really, really close. This is it. That's as far as you can go. Nothing's going to cancel. This is not the same. X plus 2 and x minus 2, I cannot make them the same. It's not like this case up here where I can factor out the negative 1. Remember, these are conjugates. If I factor out the negative 1 from this, I'm going to get negative 1. I'm going to get negative x plus 2, which is not the same as this. So that won't cancel. So this thing is done. I still need to do my restrictions. Okay. Anything in the bottom is a restriction. So x cannot equal 0, negative 3, positive 2, positive 1. Are there any other ones? There's those 4. Yeah, those are the only 4 we had all the way through the problem. So those are my only 4 restrictions. Okay, let's move on. Whew. Yikes, this one looks a little bit bigger, but notice I got an x on the top, I've got an x cubed. If I can factor out, I can simplify this thing first. That's what I'm going to do. Let's do it. So the top is 5x. Great. What is the bottom? X, factor it out, and I'm left with x squared plus x minus 6. Recognize that? That's a trinomial. Two numbers multiplied to 6. So it's got to be 6 and 1. No. 3 and 2? Yes. Plus 3 minus 2. So you know what? I'm going to do that right now. Plus 3 minus 2. X plus 3. X minus 2. There's my first one factored. Plus x minus 8. That's already done. But what about this one? X squared minus, oh yeah, two numbers multiplied to 24. So 8 and 3, yeah. Positive 8? No. There's more minuses than plus. So x minus 8, x plus 3. Okay, this x will cancel right off the bat. And x minus 8 and x minus 8. Actually, you know what? I'll do it like this. X minus 8 and x minus 8, they cancel. So what am I left with? 1 over x plus 3. What am I left with over here? 5 over x plus 3, x minus 2. X plus 3 is already common. That part's done. But the x minus 2, I need an x minus 2 over here. That way I would have a common denominator. So let's do that. Let's multiply in x minus 2. Now, I can't just do that. That's changing the question. However, if I multiply it top and bottom, there we go. Now I've actually multiplied by 1, and that's completely legal. Yes, legal in all 10 provinces and 3 territories. Here we go. So now that I have the same denominator, right? The denominator is x minus 3, x plus 3, x minus 2. The top is going to be 5 plus 1x and then minus 2. So 5 plus 1 times x, so x and then minus 2. Now, you can't cancel like this. Don't do that. No, that does not work. Let's not do that. That does not happen. Okay, that's not what I want. That does not cancel. That does not cancel. Because I need to simplify. I need to put stuff together and then factor. Okay, well, let's do that. Look at the top. The top is x, 5, and minus 2. So there's x plus 3. Now I see it. See, the denominator was x plus 3 and x minus 2. Now that it's factored, and this is in factored form, right, that will cancel. So I'm left with 1 over x minus 2. There's my final answer. Yikes, that was a lot of work. I need to do restrictions, right? At any point in the question, if it was in the denominator, like there, all of these factored things are going to be my restrictions. X cannot equal, well, I know it's not positive 2. I also know it's not minus 3. What else? 3, 2, 3, 2, 3, 2, 3, 2, 8. There it is. Positive 8, right? Because if I had plugged in 8 into here, it would have given me 0 over 0. And, oh, there was also an x here. I scribbled it out. I should have highlighted it. But the x, so if you put in a 0 for the x there, that's another restriction. 4 restrictions. Okay. What about this one here? What do we got? 1 over and 3 over. So two numbers that multiply. So this is going to be 1 over x plus 4, x minus 3. Hang on, do I have that right? They multiply to negative 12. They add up to 1. So positive 4. Yes, there's more positives than negatives. And over here I've got 3 over x minus 3. See, the x minus 3 is already common. X plus 4, that's what I need to put in. So let's put in an x plus 4. So I'm going to multiply the right-hand side over here, both top and bottom, by x plus 4. X plus 4. Okay, so when I do that, now I have a common denominator. So what do we have? We have the common denominator, which is x plus 4 and x minus 3. On the top, I've got 1 plus 3 times x, 3x plus 3 times 4 is 12. Hang on, this looks familiar. Was this our first question? Oh yeah, it's the same one. I cut and paste this one. It's going to be the exact same question. But we know, I can tell at this stage, this becomes 3x plus 13. It's done. Nothing will factor out of those, right? This was x plus 4, x minus 3. There's my two restrictions. X cannot equal negative 4, positive 3. Okay, let's get into some uglier ones. Yikes. Look at the size of this beast. This is a trinomial on the bottom. I know it'll factor. Notice a lot of these trinomials, they're easy ones. They usually start with a 1. So they're ones you can factor in your head. Okay, so let's try this one. X plus 3. What do we got? Two numbers multiplied by 6. It's either 6 and 1 or 2 and 3. Now they're positive, so they're either both positive or both negative. They're both negative. X minus 2, X minus 3. Oh, I was expecting these to cancel. They don't cancel. They're not the same. Okay, what about over here? I've got 6 on top. The bottom, I've got two numbers multiplied to 12, positive, and they add up to 9, so they're both negative. X minus multiplies to 12, 4 and 3. So minus 3, minus 4. Okay, that's good. X minus 3, X minus 3. That's part of my LCD. Okay, now I'm going to do it. Let's do the LCD. Because they do have something in common. They have X minus 3 in common. So the left one is X minus 3 times X minus 2. There's my left denominator. My right denominator is X minus 3, X minus 4. So there it is. 1, 2, 3. I want to have all three of those factors in the bottom. This left fraction, I'm missing the X minus 4. So that's what I multiplied top and bottom. And the right one, I'm missing the X minus 2. Multiply top and bottom. Okay, let's do that. Let's do that right now. This one, I'm going to multiply by X minus 2 on the top and the bottom. And this one, I'm going to multiply by, that needs to be in brackets now, X minus 4 on the top and bottom. Done. So let's expand all this stuff all out. What do we get? Whoa. So see the denominator? X minus 4, X minus 2, X minus 3. It's the same on both sides. So now I can write it as one huge fraction. And that's what I'm going to do. I'm going to write it as 3 factors. X minus 2, X minus 3, X minus 4. But the top is going to be, this is a trinomial, and this is 6 times, okay, so what do we got? This is going to be x squared plus 3x minus 4x, and then minus 12, plus, careful, if this is a minus, I would have to subtract both, right? But luckily it's a plus. So 6 times x, 6x, and 6 times minus 2, minus 12. Okay. Whew. The bottom's already factored. The top is some big, probably a trinomial, x squared, x, and numbers. So let's start putting stuff together. What do we got? I'm going to do the bottom first because the bottom's already done. Right? X minus 2, x minus 3, x minus 4. This becomes x squared. So minus 4 and plus 3. So minus 1 plus 6 is plus 5x. Minus 12 is minus 24. Oh, this is one that'll factor. This is an x minus 8. Hang on, what is it? Two numbers are multiplied at 24. 8 and 3? 8 and 3. So, once again, okay, let's do the bottom first. X minus 2, x minus 3, x minus 4. I'm being rigorous. I'm showing this every step because it's still there. The top is going to factor in 2. 8 and 3, so positive 8. X plus 8, x minus 3. Luckily, what do we see? Those two are going to cancel. It's the same factor, top and bottom. X plus 8 and 4, no, those are different. But those two are going to cancel. So here's what I'm left with. X plus 8 on the top. And the bottom is just the two factors. X minus 2, x minus 4. Done. I need to do my restrictions. X cannot equal, you remember if at any time it was in the denominator, there it is, 2, 3, and 4, right? Positive 2, positive 3, positive 4, because those would give me zeros. It's not negative 3, it's the opposite, it's positive 3. 2, 3, 4, 2, 3, 4. Really, that lowest common denominator, that's where you're going to find those restrictions, and that's where they were. Okay, that was a long question. What about this one? This one's going to be even worse. Oh man, look at all this. But I'm expecting a whole bunch of stuff to cancel. And besides, this is a plus and a times. Remember, you always do the multiplication first, right? You multiply before you add. So I'm going to try and simplify this stuff down. I can see a whole bunch of things going on here. And then I'm going to add it on. So This one is simply x minus 2, x plus 5. Can't cancel individually, it just has to stay there. But this thing, let's factor everybody. This is two numbers multiplied to negative 3. So x minus 3, x plus 2. No, so x plus 1, yeah, because they add up to that. The bottom is going to be 3 and 2, yeah, and they add up to negative 1. So x minus 3, x plus 2. Guess what? Those are going to cancel, even before I do anything else. Times, no, I can do that better than that. This is not a difference of squares, but I can factor out the x. X bracket x plus 2. This is not a difference of squares, but I can factor out the x. X bracket x minus 4. Okay, now let's start doing some canceling stuff. X plus 3 is cancel. X is cancel. X plus 2 is cancel. Whoa, so I'm just left with this over this. So that simplified a lot. So hang on, x minus 2 all over x plus 5. Hang on, shouldn't this minus 2? No, no, no. This is a separate fraction. I'm simplifying in this one first. Plus, what am I left with? X plus 1 over x minus 4. That's all that's left. Okay, now, so it's one fraction plus another fraction. When I'm adding fractions, I need a common denominator, and these two don't have anything in common. So the LCD is really just going to be 1 times the other, right? It's going to be x plus 5 times x minus 4. So I need both of those. So let's put them in. Yay, let's do this in red. So here, what am I going to be multiplying top and bottom? I need the x plus 5. I have to do it to the both top and bottom because that way I'm multiplying by 1. Here, what am I missing? I'm missing the x minus 4. X minus 4, x minus 4. So I need to multiply both top and bottom. Okay, so let's get back to this. I now have a common denominator, which means I can write it as one big fraction. It's going to be x minus 4 times x plus 5. There it is. And on the top, I've got this trinomial plus this oh man, this is a lot. Okay, so x squared minus 2x minus 4x plus 8. Okay, that's the first one. Plus, what's this one? It's going to be x squared, x times 5, 5, and x times 1. 1 and 5 is 6. 6x. 1 times 5 is plus 5. There we go. So I skipped that middle step. I just combined those. So hang on. X squared, 2x squared. Oh yeah, this is all in the top. Minus 6x plus 6x. There's no x's. I don't need to write 0 x's. I can just leave it blank. Okay, so let's do that. And what are we left with for numbers? Plus 8 plus 5 is plus 13. Nothing factors out of that. That's done. So I'm pretty sure that this is my last step because nothing's going to simplify. That's not a difference of squares. It's not a difference. It's not a nice number. X minus 4, x plus 5, done. Last step. I always forget about this. Let's do my restrictions. X cannot equal, I know, positive 4 because that would give me 0. Negative 5. Okay, what else was the denominator? 4, 5, 4, 5. Oh, back up here. See the 3? It canceled out, but it's still a restriction. So positive 3. The x plus 2 canceled out, which means negative 2. Oh, and the regular x all on its own right here. Well, that's like saying x minus 0. Sometimes they write it as x minus 0 as a factor. Big deal. If I was to just plug in 0, that would be the problem. Okay, so yikes. That was a bigger question too. Okay, now let's get to this last part. This one is called complex fractions. Yikes, this is pretty big. Here's what it is. I've got a fraction plus a fraction, all divided by a fraction minus fraction. Now, I could do this in 2 steps. I could go this fraction plus this fraction. I'll figure out that answer. Then I'll go this fraction minus that fraction, that. And then I'm going to do something, divide by something. I'm going to do it as a whole bunch of steps. You could do that. But you can see I got to get a common denominator of 2a. Here I've got to get a denominator of a times a plus 6. That's going to be a lot of steps. I could do that. I'm going to show you a shortcut. It's kind of cheating, and it's awesome, and it works. We're going to do this next year again in 12 too, but we're going to be doing it with trig functions. But here's what I'm going to do. Watch. Let me just make something up with numbers. What if I said 3 over 2, right, divided by, I don't know, 5 over 4, right? Okay, so some fraction divided by, okay, I could do, but watch. What happens if I multiply top and bottom by 4? Why 4? I just chose 4 because it's the common denominator. 5 times 4, these cancel, don't they? And I'm left with 5 on the bottom. It just became easier. And if I multiplied over here, 3 over 2 times 4 is really 12 over 2 is 6. So those fractions disappeared real fast when I multiplied by the LCD. And I did it on the top and the bottom because that way, remember, I've multiplied by 1, a really weird form of 1, but it got rid of the fractions and it gave me an easy fraction, an easier answer. So that's what I'm going to do, but I'm not going to do it with numbers. I'm going to do it with algebra. Okay, let's do it. Here's what I'm going to do. I'm going to figure out what the LCD is, the lowest common denominator. I know it's got an A in it. And I know it's got an A plus 6, so it's really A times A plus 6, right? It's got to be 1 times it. You can't just go plus 6. No, I'd have to multiply them. Oh, and it also has to have a 2. So that's the LCD. It's going to be 2 times A plus. It's all 3 factors. So here's what I'm going to do. I'm going to multiply it on the top. Let's get rid of that. We'll just go 2A bracket A plus 6. A. Come on. A. And I'm going to multiply it on the bottom. 2 times A plus 6. Watch. When I multiply it by here, the 2's cancel. See that? 2 cancels. Okay, well, I don't want actually to disappear. Don't get rid of that. Don't get rid of that. When I do it here, the A is going to cancel. See that? And then the other parts would stick around. But actually, let's bring that back. And when I do it over here, see the A plus 6 is going to cancel. So every time I multiply it in, all the denominators are going to cancel because I chose something that all of the denominators have part of. Now, this is a big beast, right? But I'm multiplying by 1. This is just a weird form of 1. Okay, multiplied in here. I know that the 2's cancel. So I'm left with 3 times A plus 6 plus A's cancel. So it's going to be 3 times 2, so 6, times A plus 6. That's the top. Okay. Now, notice the 2 canceled, the A canceled. That's the whole point. There's no fractions here. I know it's big, but I can simplify this. Same thing's going to happen here. When I multiply it into here, the A plus 6 is going to cancel. So I'm left with A times 2A. 2A squared minus 1 over A. When I do this, the A is going to cancel. So I'm left with 1 times 2. So 2 times A plus 6. Okay, now this is a little bit bigger, but at least the fractions are gone. So let's expand all this stuff all out. So this is 3A times A plus 6. So this is 3A squared plus 3A times 6 is 18A plus 6A plus 36. On the bottom, I've got 2A squared minus 2A minus 12. Okay, it's still pretty big, but I can start putting stuff together here. What do we get? Okay, so you know what? I'm going to 3A squared, 18 and plus 24A plus 36. That's a trinomial. You know what? They're all divisible by 3. I can factor out a 3. Actually, let's do that right now. If I was to factor out the 3, 36 becomes 12, this becomes 8, and the 3 I can divide out. 8, 12. And the bottom is 2A squared minus 2A minus 12. Looks familiar. It's a trinomial. They're all divisible by 2. Let's factor out the 2. Let's do that. 2 bracket A squared minus A minus 6. I bet you these things will factor. They're trinomials. I bet you they'll turn into, okay, hang on. Let's try this. I got the 3 and the 2. I factored those out. What are these things going to factor into? 2 numbers multiplied to 12. Add up to 8. So it's either 12 and 1. No, 2 and 6. Yes, they're both positive. X, A, careful, not X. a plus 2, a plus 6. What about the bottom? Two numbers multiplied by 6, 6 and 1 or 3 and 2. They add up to negative, which means it's got to be a plus 2, a minus 3. There it is. In this question, they cancel in the very, very last step. So here's what you're left with. Okay, bring it on. 3 bracket a plus 6, 2 bracket a minus 3. That's in factored form. Now, if you want, you could really make this 3a plus 18, but did it really change anything? No, not really. And you could make this 2a minus 6, but who cares? These are both expanded. These are both factored. In the factored form, I can see that nothing is going to cancel. These don't cancel. They're not the same. That's it. So this entire thing simplifies down to that. This is a big question, but here's what I did. In the very, very first step, I identified the LCD and I multiplied it top and bottom just to get rid of these minor denominators. All these denominators disappeared and it turned into this. Then from here, I simplified that down, get it to factor, and luckily something canceled in the last step. Now, I have a lot of restrictions. What can A not equal? Well, all of the denominators, right? Remember, all these denominators over here. So A cannot equal 2. Well, 2 is not equal to 0. Trust me, that one's okay. A cannot equal 0. Negative 6. Okay, is that it? Oh, there was also denominators here. 2. Oh, yeah. See, there's a negative 2. So this one brings in, and what about minus 3? Positive 3. It brings in 2 more restrictions. Ah, okay. There's all the restrictions. Okay, let's do this one more time. Let's bring this back. Okay, look at this beastie. This fraction minus this fraction and this fraction. Oh, okay. So 2m minus 3 is going to be part of my lowest common denominator. I can already tell. So let's do the LCD. The LCD's got to have a 2m minus plus 3. What else? It's also got to have an m. Oh, it's got to have an m squared. So in other words, it's going to be m, well, it's going to be there twice. I don't need to say m and m squared because just multiplying by m twice, there's my m squared. See? So the m squared is going to cancel here anyways. So careful, I'm not multiplying it top and bottom. I'm multiplying this all into the top here because I want this to cancel. And I'm multiplying it into the top there because I want that to cancel. So that's really what's going to happen. Okay, so let's do this. Here we go. 2m plus 3, m squared. When I multiply it here, one of the m's cancels. Right? So I'm left with 3 times this thing. 2m plus 3 and m. So 3 times m times 2m plus 3. Yikes. Minus 3. Now when I multiply it here, the 2m plus 3 cancel, but I'm left with these 2 m's. 3m squared. Okay, so there's the top. Let's do the bottom. When I multiply all 3 of these by here, the m squared cancels, and I'm left with 2m plus 3 times 3. 3 bracket 2m plus 3. Plus this, I'm going to multiply here. The 2m plus 3 is going to cancel. I'm left with 1 times m squared. Now, careful. Don't do this. They don't cancel. You can't cancel individually. No, 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 no. I can't do that. Come back. Don't do that. Don't do that. What I can do is I can expand and put all this stuff together in the top and then factor it. Because you see, I've got a 6m squared, 3m times, I got 6m squared there, and I got a 3m squared there. I know I can put this stuff together. So let's do that. Here we go. 6m squared plus 9m minus 3m squared. There's the top. The bottom is 6m plus 9 plus m squared. Looks familiar. That's the bottom is a denominator. Oh yeah, that's a trinomial. Look at the denominator. It's m squared plus 6m plus 9. And what's the top? The top is 3m squared plus 9m. I'm not done yet. I can't cancel individually, but I recognize the bottom. I do recognize the bottom. It's 2 numbers multiplied to 9 and add up to 6. It's got to be 3 and 3. m plus 3, m plus 3. The top's not a difference of squares, but I can factor out 3 from both of them, and I can also factor out m. So when I divide out the 3m, I'm left with m plus 3. There it is. There it is in that final step. Now this cancels. Plus 3 plus 3. So my final answer is 3m over m plus 3. Yay, that's completely simplified. Okay, what is m not equal to? Well, obviously minus 3. It's in the denominator. What else? M is 0. That's a restriction right there. 0. And what about this one? So if I said 2m plus 3, if I set that equal to 0, I'm going to get negative 3, and I'm going to go divide by 2. So negative 3 on 2. So negative 1.5. That's also a restriction. Yeah, because 1, 2, 3, those ones, and those ones. Okay, so the second part, this is a lot of work. Question 6 and question 7. Now, if you take a look at the stuff from Tuesday, I already had the answers for all of question number 6 and 7 and 8 are on there. So I am going to ask you guys to finish up whatever 6 and 7 is there. Question number 10 is a good one. This has to do with the complex fractions, what we just looked at. And 15, now I'm going to put all the answers for 15 on there, so you might as well do all of them. But yeah, these are tough. These are the last ones, much like here, where you had a number of steps. Alrighty, good luck with these things.